This is Lab 6, Faraday rotation and stress optic coefficient.
And fundamental concepts of this lab is the magneto-optic effect, which is when you apply a magnetic field to an electromagnetic wave in order to change its properties. We can do that with this Faraday rotator here, and it's worth learning about because we could use a Faraday rotator as an optical isolator along with a few other optical elements to show reciprocity versus non-reciprocity. The Faraday rotator is a non-reciprocal system. So we could also use a Faraday rotator as an optical isolator, which is super helpful in terms of optical communications to stop back reflection from happening inside optical fiber.
So another key concept for this lab is understanding stress optics and how does stress and strain in our optics affect the transmission of certain materials. So learning about this concept is particularly important for when you are designing large optics, especially those that are going to be under gravitational stress and forces.
For our setup when we were using the Faraday rotator, we had some issues getting accurate data because the analyzer we were using was just difficult to read, and the power meter we were using fluctuated a lot, and we couldn't get a very good measurement out of that. And that shows in the plots that we have, and really those were the major sources of error that messed up our results to whenever we tried to do our isolator, that we didn't get a full 100% extinction.
From the stress optics experiment, we found a peak transmission induced at 900 newtons of force per 1 centimeter square area, and we found the stress optic coefficient Q to be 4.25 times 10 to the negative 11 meters squared per newton. So the results, comparing to what we knew previously from lecture, the stress optics worked as we expected. We saw a peak in transmission at that force level of 900, and then on either side it sloped downward.
Overall, we really like this lab. It was pretty straightforward, especially for the stress optics. But for the Faraday rotators, we had some issues trying to get the correct voltages and actually getting the correct angular data. So, and you will see that in the results as significant error.